So the purpose of this lecture is to make you kind of badass at SPSS. So we will talk about test and item analysis, which is the content. And some of you will do pieces of this for your dissertations, particularly if you make your own measurement instrument. But this is kind of where I show you inside secrets and how to do stuff that you're going to have to do probably on your dissertation. And I fit it in contextually with this particular topic. So let's do it. So, when does one evaluate a measurement instrument? Well, when you want to evaluate the quality of, say, some sort of multiple choice test that you got, so the overall quality of the test in terms of reliability or in terms of pass rate, or that would be your test statistics. And when you want to know not only how good is the overall test, but how good are the individual items and the answer choices. So those are what we call item statistics, and that is pass rates for items and distractor selection rates and item total correlations, which you'll learn about. But basically, the way you make a good test is you make good items. It kind of works that way. So some examples. The Department of Consumer Affairs needs to determine whether the exam for MFT candidates, so that's something else now, right? It's like family and child therapy, is fair across different forms of the exam used throughout the state. So, and that the forms are similar in terms of difficulty. So one of the things that they do is they make different forms, and this is real, by the way, to get your CFT or whatever it's called now license, you have to pass an exam, and there's more than one version of the exam. But what if one exam version was really hard? That wouldn't be fair, right? So they actually do a test analysis to ensure that they're equal in terms of difficulty, and that is when you use this sort of thing. So this is where I used it in my career. I did some psychometrics. So in case I didn't tell you guys, I wrote that DMV exam back in the day. So that thing you got to take to get your license, that was me in the 2000s. It hasn't been for about a decade, so it does kind of drift over time. But I wrote that, got rid of all the crap and put ones on there that were actually in the book, the answer, got rid of the ones that were mathy, how many feet to break, that kind of stuff. So that was something I did back in the day. Anyway, so psychometrics, you learn it as part of experimental psychology. So I was at DMV for a while, as you know, and I had to determine the quality of the written knowledge test for drivers who were renewing their license. And as part of doing that, we actually, like I said, look at the individual items that make up each form. And there's 10 forms, 1 to 10, of each test. So we did a full-on item analysis and a full-on test analysis. So let's talk about test statistics first. So test statistics help you identify tests that are deficient. So helps point out tests that have got some problems. So you're going to need to fix the items, really. So statistics for the test evaluate the test overall. You've got your fail rate. So it's if there's failing on the thing that you're evaluating, it's a percentage of applicants who fail each test based on the standard of competence. So if you allow 3 errors, then it's the percent who fail at your standard of competence of allowing 3 errors. So your fail rate, not shockingly, can range from 0 to 100%. It's just a percentage. And it's how many fail the test at the existing passing standard. So for example, 30% fail DMV's written renewal test if you allow them to miss no more than 3 items out of 18. That is the current standard. And that's the fail rate. So good tests have fail rates that are similar across different forms. So the 10 forms of DMV's test that we made had similar difficulty across them. It's not exact. You guys know the whole a skittle up or down, right? A couple red skittles up or down, but basically they were equally. There wasn't one that was super easy or one that was super hard. So another test statistic that we look at is called mean number of errors. It is exactly that. It's the mean number of items that folks miss on the test. It's different than the fail rate because it's continuous, right? The fail rate is people dichotomously pass or fail. Mean number of errors gives you sort of more information about the underlying why they failed. Did they fail a lot or just a little? So it ranges from 0 to the total number of items on the test. Good tests have similar average numbers of items missed across test forms. So again, here's a new one. So actually not new. It's new for you to do. So do you remember internal consistency reliability? It's called alpha or Chromebox alpha. It's out there for pretty much every psych test, and it was a measure of reliability. So Chromebox alpha, it turns out, is super easy to calculate, and SPSS, we're going to do it on this homework assignment. And it indicates the degree of uniformity among the items on each test form. So how much they tend to be answered similarly across all items on the test form. Remember, this is that all possible split halves. It's the average correlation of all possible split halves of a test. So it's on average how much performance on one half of the test correlates with performance on the other half. So it is a positive correlation, so it ranges from 0 to 1. Higher numbers indicate higher reliability. 1 is that you've got perfect homogeneity among your content. The score that they get on one half the test is always exactly what they get on the other half. 0 indicates you got a huge problem. Your test is not reliable at all. You've got some lack of similarity among the items. They do not appear to be measuring a coherent construct. And good tests get somewhere closer to 1, so that would be good. That would be perfect reliability. And typically the standard is 0.7 or higher for a test to be acceptable. So you want a Chromebox alpha of 0.7 or higher. We also look at cut point selection. So we'll do that also on the assignment. You determine percentages who would pass at different numbers of allowable errors. So what if we allowed 4? How much would pass? What if we only allowed 2? What percent would pass, etc. And it's done to help you choose an appropriate number of allowable errors and get the desired passing or fail rate. So those are your test statistics. Now let's talk about item statistics. These are about individual items or questions on an exam or a questionnaire. So we have item pass rates. So item pass rates are the percentage of applicants that select the correct answer choice for each item. So that's the percent who pass each item. And good item pass rates are somewhere from 60 to 95%, but not less than 60 and not more than 95. So that means 60 to 95% of people pass the item. So we look at the overall, so the percent who picked the correct answer is your item pass rate. We also look at the percent who picked the wrong answers, each wrong answer, and we call those your distractor selection rates. So those are the percentage of applicants that select each incorrect answer choice, which the fancy name for that is a distractor. So good distractors get more than 2% of people picking them, is the way to say this, I guess. So you want some people to pick it, but you don't want too many people to pick it because it suggests it might kind of be a right answer, right? So the rule is more than 2% pick each wrong answer choice, because if no one picks it, it's not really distracting anyone, right? So you want at least more than 2% to pick, but you don't want the percent who pick it to be so high that it's within 20 percentage points of the correct answer, okay? So the item pass rate, basically. So you want something that's, some people pick it, something greater than 2%, but you don't want too many that is within 20 percentage points of the correct answer choices selection rate. So 2% of people choose the wrong answer, but it's not chosen almost as often. That is within 20 percentage points, or even worse, more than the correct answer. that means you got a big problem. So there's also an item total correlation, and item total correlations indicate the degree to which performance on the items correspond with performance on the rest of the test. So there are correlations of performance on each item with correlation on the rest of the test, the total score, basically. And they're super useful. So good items are those that tend to be answered correctly by people who perform well on the rest of the test, right? So if you got an item that people who tend to do well overall on the test tend to do well on this item, you will have a positive item total correlation, and that's a good thing. That's what you want. Bad items are those that tend to be answered incorrectly by applicants who scored well on the rest of the tests. So if you get a negative item total correlation, it means that the people who tend to do better on your test do worse on that item. So like, why? It's probably a really bad item. I mean, you tricking them. Is there, another right answer and you're just not realizing it? So that's one criteria. You don't want negative item total correlations. Those are the worst. But also, there's items that are just basically not really related to the rest of the test. So those have item total correlations that are basically 0. And how do we define that? There's no significance test here. Well, anything that's basically negative 0.1, between negative 0.1 and positive 0.1 is really small correlation, right? These are just correlation coefficients. So, I mean, anything negative is bad, period. You can think of it that way. So if I see negative, it's bad. But if the correlation is so small that's between, has absolute value that's 0.1 or lower, that performance on the item is just not even associated with performance on the rest of the test. So whether someone gets that item right or wrong is totally unrelated to the performance on the rest of the test. That's what basically 0 item total correlation indicates. So there's 2 criteria for bad items. There's 1 criteria for good items. So the implication here is that good items not only have a positive sign, but they're bigger, they're 0.1 or bigger, right? That's what you want. So, oh yeah, there's one lady pointing in the wrong direction. Bad item total correlation. So that's it. None of this is hard. So it's really just an exercise in teaching you to do some fancy stuff in SPSS that you might need to do on your dissertation. Most people do. So we are going to evaluate DMV's form number 1 of their renewal driver license test. There are 18 items on that test, and you're allowed to miss 3 when I evaluated it. So the data format in SPSS, again, we don't do A, B, C, or D. There's 4, actually there's 3 possible answer choices. We don't do A, B, or C. We use 1 to stand for A, 2 to stand for B, 3 to stand for C. And then there's some other numbers in there that is sort of new for you guys, because sometimes people don't just pick A, B, or C. Sometimes they pick multiple answers. So how do we code that? Sometimes they don't pick any answer. How do we code that? So 1 is used for A, 2 is for B, 3 is C. 8, if you see it in the data file, means that person, because these are real data, by the way, that means that person picked more than one correct or more than one answer, and that's also wrong. And a 9, if you see it, means that they didn't answer the question, so that's also wrong. So here is what the data file looks like. There's no 8s and 9s up here in the top 10 or whatever people, but you can see each row is one person, and underlying those A, B's, and C's is 1, 2s, and 3s. So let's do our item statistics first. That's customary. So we're going to look at individual items before we look at the whole test. So specifically, let's look at our item pass rates. And again, item pass rate is the percentage of applicants that select the correct answer choice. And we're actually going to use that valid percent thing that shows up in the frequency distributions for this, because we want to know of those who selected a valid answer, what percent picked A, B, or C. Not of all people who were in the study or took the test. We want to know of those who picked a valid answer, what percent picked A, B, or C. So we're actually going to use valid percent for once. So, excuse me, here's the first 4 items. And on the first page of your homework assignment, it does tell you what's the correct answer. So like for item 1, is it A, B, or C? I'm going to tell you here, but do note for the one you evaluate in your assignment, it does tell you what the correct answers are on the first page. So let's do it. So these are just frequencies of responses to each item. That's all this is. There was 305 people in the study, and let's see how they distribute. So the answer key tells you what is the correct answer again. And we want to identify items here that are probably bad because they have a low item pass rate. That would be less than 60% get the item correct. So that's less than 60% choose the correct answer. or they're too damn easy. So they have an extremely high pass rate of 95% or greater than 95%. So we want that sweet spot between 60 and 95. We don't want less than 60 and we don't want more than 95. So for item 1, A was the correct answer choice. And looking at valid percent, you can see that 76.7% of people picked that as the correct answer. They got it right. That is the item pass rate is 76.7%. So is that less than 60? Nope. Is that more than 95? Nope. That's a good item pass rate. That is a good one. So it's okay. How about item 2? Correct answer for item 2 was also A. And 98%, using the valid percent, 98% of people who took the test picked that. Is that a good item pass rate? No, right? That's too easy. Too many people get this item wrong. It's higher than 95%. Too easy. That's too damn high. So I'll tell you how you fix that. Usually what you do is you make the distractors more distracty. So note that like only 1.3 and 0.7 picked the wrong answers. The way to lower the item pass rate without ruining the item is try to come up with better wrong answers. For item 3, B was the correct answer. And 81.6% of folks picked that, and that is between 60 and 95, so that's a good item pass rate. Notice for item 3, there's no answer choice C. If no one picks C, it won't show C in the frequency distribution. So we already know whatever distractor is C, it's awful. No one picks it. All right, but the pass rate's okay. That's why it says okay. So for item 4, the correct answer was B. 94.4% of people picked that. Is that within the range of acceptability? It is. It's between 60 and 95. Note there was one person here that didn't pick an answer choice. So this is finally a case where the percent and valid percent do not match. You see that it's 94.1 by percent. Valid percent is the percentage of those who actually gave a valid answer, and it was 94.4. So that is 9 is missing. So is 94.4 between 60 and 95? Yes, it is. This item is okay in terms of pass rate. So you do that for every item on the test. So the next item stat we're going to do is distractor selection rates. And this is for each item, the percent who pick each of the wrong answer choices. And again, we want that to be something greater than 2%, but not within 20 percentage points of the correct answer choices selection rate. All right, again, we're going to use valid percent, and we want to find distractors that are probably bad because no one picks it. It's 2% or lower. And we also don't want distractors that are selected within 20 percentage points or more often than the correct answer. That means you got a serious problem. Why are so many people picking that supposed to be wrong answer? Usually it turns out it's not a wrong answer. So be aware that if no one picked an answer choice, it doesn't show up on the SPSS output. You do have to remember to fill it in when you write it up. So here is items 1 through 4 again. For item 1, the wrong answers, the distractors, were B and C. There are the the distractor selection rates. Those are definitely greater than 2%, so those are very distracty. Those are good distractors, and they are not within 20 percentage points of 76.7, the correct answers selection rate. So those are pretty good distractors. They're not too hard, not too easy. They're pulling off some people. Sweet. How about item 2? So item 2, B and C were also the incorrect answers, and 0.7% picked B. That was 2 people, and 1.3% picked C. That was 4 people. Are those a problem? Yes. Why? Well, basically no one picks them, right? So we want a distraction selection rate that's greater than 2%. Neither of those are. Those items need to be, or those distractors need to be made more attractive so that some people start picking them, and that will also reduce the item pass rate within the range that we want. So both too low. How about item 3? Well, item 3, first of all, 18.4% picked A that as a wrong answer. So that is not that's greater than 2%, and that is not within 20 percentage points of 81.6. So that's a good wrong answer. Is there a problem though? Yes. Where's wrong choice C? Well, 0 people picked it. So it has a 0% selection rate. It is really bad. We got to come up with something better for answer choice distractor C. So for item 4, we got 3, that's greater than 2, and 2.6, that's greater than 2. Neither 3 nor 2 is within 20 percentage points of 94.4, so that's a good item. Pretty good item. All right, continuing with item statistics, let's look at our item total correlations. So again, these are correlations for each item, and they indicate how performance on the item corresponded with performance on the rest of the test. So it's a correlation of whether they got that item right or wrong with the total score that they got on the test. So you want positive. People who tend to get that item right tend to do well on the overall test. You don't want ones that are negative or basically 0. So you do have to have SPSS grade the test, and you'll make item variables for your assignment. And this is where I get you into compute. And this is what your item total statistics table looks like. Corrected item total is the correlation of each item with performance on the rest of the test. Again, you want to identify items that are likely bad because they have corrected item total correlations that are negative. That's bad. Just looking up there, I don't see any negatives. There's no signs that are negative on any of those. So we don't have any negative item total correlations, but we also don't want ones that the absolute value is less than 0.1. Okay, so that, again, it's just a correlation. So if the correlation is less than 0.1, it tells you, yeah, performance on this item is not really related to performance on the rest of the test. It's like having no correlation, okay? So it's a little weird because you have to think in your head, is this less than 0.1? Then I got a problem, negative or positive. And then any negative is bad. So let's do it. Let's find the problem. So there's one. Item 3 is correlated only 0.08 with performance on the rest of the test. That's less than 0.1. It's basically not related. You could drop item 3 and actually the test would be better, be more cohesive. How about the next one? That would be, the next one that is a problem is item 5, right? That's less than 0.1. Again, performance on this item not associated really with performance on the rest of the test. Item 7, same problem. This item is really bad. Item 8, also not really related to performance on the rest of the test. Same thing for 9. Then we got a whole string of good ones, right, until the very end. Item 18, yeah, you know, whether someone gets this item right or wrong, totally unrelated to how they did on the rest of the test. And hopefully that sounds bad to you, because it is bad. You want the items to all contribute to the overall test score, not some of them. So what is that? 1, 2, 3, 4, 5, 6 items that have too low of an item total correlation, 0 that have a negative. All right. So now let's switch to test statistics. So again, these are about the overall test, not just individual items. So let's look at the fail rate of the test. And the fail rate is just the percentage of applicants that fail the test, that get below some cut score. And you will need to use SPSS on the assignment to count the number wrong for each applicant. So it will go through and count the number of items that each person missed. And so this is what a frequency distribution of, I just called it wrong, looks like. So it goes from 0 to 10. Remember, it's an 18-item test, so someone missed 10 out of 18. That's crazy. And some people missed none. So the department standard for passing is you can't miss more than 3. So if you missed 4 or more, you failed, right? So your fail rate would be the cumulative percentage of those who were 4 or higher. So we know that 69.8%, and I know you guys love this column, cumulative percent, allowing 3 errors. And remember, what cumulative percent tells you is the percent who were at that score, in this case 3 or lower, right? So 69.8% of applicants at the DMV for the renewal missed 3 or fewer items. That's actually the pass rate. We need the fail rate. So how are we going to turn that into the percent who failed? Easy math. 100 minus 69.8 gives us 30.2. 30.2% of applicants failed test 1. Mean number of items missed is literally just the mean of what we were just looking at. So it's a little circular. You will run descriptive statistics for the number wrong. And I did a little histogram. I probably should have got a skewness coefficient for you guys because we don't really use histograms. But what do we got here? So the mean number of items missed on here, look to the mean, is 2.86. So on average, people missed 2.86 items on Form 1 of DMV's test. I got the median, and I also got the standard deviation. So mean number wrong is 2.86. So finally, we want to look at the test statistic for internal consistency reliability. So this is Chromebox Alpha, and it sounds scary, but it's not. It's super easy to do, and you're going to blow your professors away by calculating this for them. So internal consistency reliability, or Chromebox Alpha, indicates the degree of uniformity of items on a test. Again, it's the average of all possible split halves of the test correlated with each other. So the higher it is, the better. You want at least 0.7 or higher to be able to say, yes, this test is internally reliable. So you'll run a reliability analysis in SPSS. They give you instructions. And I'm sure you totally recall what we learned about reliability last semester. High is good. Good reliability is typically 0.7 or higher, Chromebox Alpha. This is it. This is what you get from the output. It's 0.492, and there's 18 items. So the Chromebox Alpha is 0.492. That's sort of the average correlation of all possible split halves of the test. And so is that good? No, it's bad. We want 0.7 or higher. That's 0.49. So DMV's Form 1 does not pass the sniff test for reliability. It's not a reliable test, meaning scores just very kind of wildly, and like people, the items do not seem to be measuring a consistent underlying construct. So yeah, the test sucks in terms of reliability, and then it's got 6 items with crappy item total correlations, some bad distractors. This test could use some work. So the very final thing is picking a cut point, which you may or may not need, but it's kind of interesting. So how do you know how to choose the number of errors to allow on something to get the fail rate or the pass rate that you want? You will count the number wrong for each applicant again, and this is that same frequency distribution where the dude missed 10 and 25 people missed 0. And the department has a current standard for failing the renewal knowledge test of no more than 3 errors, so we determine that's a 69.8% pass rate. So what would the pass rate be if they allowed 4 errors? So this is pick and cut points. So if we allowed 4 errors, what would we do? Well, instead of using cumulative percent for 3, we would use cumulative percent for 4, and 82.6% of people we would predict would pass DMV's test if they allowed 1 more error. Big chunk. What if they only allowed 2 errors? What percent would pass? Well, look at the cumulative percent for 2. Wow. Not many. 47.5% would pass, so that would make it much harder, right? So you can kind of see this is how you find that sweet spot for your picking your pass rate that you want or getting close to your fail rate. So that's kind of it. I hope you have fun on this assignment. It's mostly just sort of learning new procedures, and reliability is kind of fun to do. So I hope you have fun. If you have questions, post them in the discussion, and I will do my best to answer them.